In this video, we are going to find the number of good pairs. Hello, this is Jagan from growwithdata. I am posting this video to share my knowledge in Python language with you. If this assists you in your interview preparation anyways, I will be happy. Welcome to the 93rd video of the Python interview question series. I have created a playlist, Python interview questions 51 to 100, and I will be tagging this video to that playlist. The code we discuss in this video will be posted in GitHub, and the link will be provided in the video description. Now, let's see the sample input data and we can talk about the question in detail. We are given two arrays, num1 and num2, and there is a constant k. So, given these three input variables, we are asked to find the good pair. So, what is the definition of good pair? If you see the pair I and j is called a good pair if nums of I is divisible by nums of num2 of j into the constant. For example, if you see this 1, right? So that's nums1 of 0. So that number, if it's divisible by any number like 2 or 4, right? So if you say 2 into the constant k, if it's divisible by the number 2 into k which is 3, so it's going to be 1 by 6. So this is not divisible, right? It should be divisible as a whole number, should not be having any decimal. So it's a no. But if you see the last one, 12, right? So 12 slash divided by, you can say same thing, 2 into 3, right? So this one is going to be 12 by 6, which is going to be 2. So this is, yes, this is divisible. So we have to find from num1 and num2 all the elements, which are all the pairs which make the good pair. So that's what we have to look for. Okay, let's see for this example what are the combinations we can make. So for here we have 1, 2, 4 and 12, right? So we can just overwrite this 2. So 1, 2, 4 and 12. Let's take the nums2. The first one is 2, right? So 2 into the constant is 3 equal to 6. So we have to find what are numbers which can come from the num1 and num2. 1, 6 and then 2, 6 and then 4, 6 then 12, 6. So here, which are the numbers divisible? 1, 6, no. 2, 2 divided by 6, no. 4 divided by 6, no. It should divide without any remainder. That's what we are looking for. So 12 by 6 is, yes, it's 2. So that works. So here we have 1. Same way, you go for the second one, which is 4, right? The nums2's second element is 4. So we take this 4 into 3 equal to 12. Now what are the numbers we can bring in? This is from num1. Same way, 1 by 12 and then 2 by 12 and then 4 by 12, 2 by 12 and then 4 by 12 and then 12 by 12, 12 by 12. If you check this, this is not properly divisible. This is not, this is not, this is, yes, 12 by 12 is 1. So this works. So here we got one more pair. So total number of pair is 1 plus 1 equal to 2. So this is what we have to look for. So here what we have to do, first you find the every element from the nums2 multiply by the constant k. So 2 into 3 and 4 into 3. Then you get every element of the nums1 and try to see if the nums2 conversion, like 2 into 3 and 4 into 3, right? If that number is divisible by the nums1's element. If it's divisible, you create a count of increment the value and then say how many numbers or how many pair are a good pair. Okay, let's start with our basic question. This is what it is. Let's go for a function def grow with data. So we have nums1, nums2 and the constant k. So first we have to have a counter variable and then we are going for I in nums1. So you get every element in nums1 and then for j in nums2. So for every element in nums1, we get every element in nums2. Now we are going to check the count is going to be incremented to 1 if the I which is the nums1's element, which is divisible by j, which is the nums2's element, into k. If that number divisible by j into k is equal to the integer division of j into k. So what is the difference between this division and the integer division? For example, you see like 9 by 2, right? You say 9 by 2, it's 4.5. So 9 slash 2, it's 4. So the double slash is called the integer division. The normal one slash is called the normal division, right? Okay, so that's what I'm doing here. You find the integer division, which removes the ratio, which is equal to the normal division. That means if there is no decimal when you do this, then if this division is proper, then you increment by 1. Else, you just put 0. You don't have to do anything. Return or return count. Let's call the function c. So it's 2, right? So that's what is expected. We got here is 1 and here is 1. So the output is 2. So how this works? For every element, we are just getting here. So first you get 1 and then here you get 2 into 4. So 2. This is 2 here. And then we are checking here. We can just do it here. So 2 and then we are going to check 2 into k, which is 3. Just 2 into 3 equal to 6, right? So now you go with this I value 1, right? So you say 1 by 6 equal to the integer division 1 by 6. So if you say 1 by 6 is going to be a fraction. Same thing if you say 1 slash 6, it becomes 0. So it's checking 1 by 6, which is 0.166 is equal to 0. Then it's going to say no, right? So no, else is 0. So it adds 0 to it. Now you go to the next one, which is 2. Same thing, we just go with 2 into 3. So yeah, 2 into 3, which is, oh, 2 is not going to go. So first you finish the j, right? So first is 2 and then it's 4. 4 into 3 is 12. Now it will check 1 by 12 is equal to 1 integer division 12. It's no, right? So it goes with 0. Same way, if the j is done, then it go for the next I, which is 2. And this is going to repeat. Wherever the divisible thing happens, like 12 by 6 and 12 by 12, then it will increment the count, which is getting this 2. If you want to get multiple test cases, then you can run the asset function. All the things are passed. So this is a very simple question. You can just do it in very fraction of seconds, right? And we can have small tweaks also. For example, we are doing the count, right, which is 0. Instead of the integer variable, if you can make that as a list, then what you do, this count is going to be converted as count dot append. Append, what happens? You just have the test case. So we have a list here. Now let's get only the function for testing purpose and see what this brings. So when I run this, it will just append to the list to check if the regular division is equal to the integer division. If you see this, true, and this is true, true, 4, and 5. So you get 5, which is not the right way. Right? Oh, here different value, 134, 134. If you have this nums, which is what you are testing now, you can just say grow with data 1248. We go with the second one. So this is going to have true and true, only 2 trues, right? So when you just do a sum of this count, then it just gives you the count of true. True is 1, false is 0, basically, right? So when you sum up the list, whichever is true, get 1. So the total value is going to be 2. So this is the list variable. Previously, we used an integer, so we just did the addition. Here, since we do a list, we just do append and make sure you do the count. And small change here, instead of doing this division, sorry, the 2 equal to, right? So we just do I divided by j into k, and then I integer division j into k. Instead of that, I can simply say I mod j into k. If that is the case, we can do the same thing. So what does this mod do? We can just say 5 mod 2. It's 1 because 2, if we divide 5 by 2, it's going to be 4. So it's going to be 4 and the remainder is 1, right? So the mod function give the remainder as 1. If you say 6 and divide by 2, it's going to be 0 because it's completely divide 6 by 2, you get 3. There is no remainder. So it's going to be 0. If you say 7 by 2, it's different because 7 is not completely divisible by 2. So you get the remainder. So that's what we are doing here. Instead of doing all this division and then comparing with other values, you simply say if the I is, when you do the mod, if it's going to be 0, then you up it. Say 14. Oh, equal to 0, right? We're going to put equal to 0. When I take the count, it will make sure you get only 2 truths. So if you do sum of, then you get 2. If you want to do more test cases, then you go here, run the asset function. Yeah, it's all passed. So here we are doing it in three ways. Both all the three are having the same code. Only changes here we are checking if the regular division is equal to the integer division. If that is the case, that means the numbers are matching. We just ignore it. Sorry, yeah. If it's divisible, then you say it's a good pair. So you just consider that value. If it's not matching, you just ignore it. Same way, instead of doing a integer count, we just do a array count. So you just create array and you append the values if it's going to be true or false. So true means 1, false means 0. So when you do sum of the array, you get how many are true. And here, instead of the cow integer, we did the array. We carry that array, but here we are doing a mod function rather than division and integer division, right? The mod basically gives the remainder of the quotient divided by the I divided by j into k, numerator divided by denominator, right? So if it's going to be 0, then it's going to be true, else it's going to be false. And I do a sum of this, which is going to give me how many are matching. If you want to see all this code, then you go to the YouTube channel, Grow with Data. In the video, this we are talking about Python interview questions 51 to 100. We have Tamil version also. So the corresponding video will have a description section where you have the GitHub link. It will take you to the code base for that video. Now we are talking about 93rd video, right? So 93rd video will have this link, which got the code base. So first we tried with the count increment as an integer, and then we took the array, and third one we just did a mod function. So all this code are here. You can use this for the practice. If you want to join the WhatsApp channel, there is a link here. You can use this and join Grow with Data WhatsApp channel. Hope you like this video and thanks for watching.